Section 1.2, Classification of Matter. When we're looking at matter, there are different terms that we use to discuss matter. Often when we look at matter, we're looking with what are called mixtures. So mixtures are combinations of substances. So let's go through a little bit of the terminology here. A substance is a pure material, which is either an element or a compound. So in nature, there are around 92 elements, and you're familiar with some of them. You're familiar with hydrogen, you're familiar with oxygen, you're familiar with nitrogen, maybe gold. Those are called elements, and elements are examples of substances. So elements are really material that cannot be broken down very easily into simpler particles. So for example, a gold atom, there's really not much we can do to break that up into smaller particles. Through chemistry certainly, but also through physical means like boiling or freezing. Atoms are pretty stable substances for the most part. Another type of substance is called a compound, and you're also familiar with these. Examples include table salt, which is called sodium chloride, or water, for example. Water is a compound. A compound is a substance that has two or more elements connected together at the atomic level. So for example, water molecules we saw in section 1.1 has 2 hydrogen atoms and 1 oxygen atom. Those 3 atoms are linked together through chemical bonds. We would call that a compound. Now, the thing about compounds is that generally we can use chemical methods, and we're not going to talk too much about those methods in this course, but we can use chemical methods in order to break them down into simpler substances. So for example, we could use a battery to provide electrical energy to break down water into hydrogen, an element, and oxygen, another element. That would be a chemical process. So a compound has 2 or more elements combined together at the atomic level. So both of those 2 types of materials, elements like gold, compounds like water, are called substances. Okay. Then there are mixtures, and mixtures are just combinations of substances. So for example, if you wanted to buy something that was 99% pure, so sometimes soaps will say they're 99% pure, or some type of oil, like you're going to buy some coconut oil, they might claim they're 95% or 99% pure. What that would be doing is it'd be telling you that the substance that you're buying, some particular oil, is 99% of the total, which means that there's 1% of something else. So the substance might be an oil, although coconut oil is a mixture of different types of oils. But if it were one specific type of oil, 99% of that oil, the 1% would be another material, so that would be a mixture. More than one substance together is called a mixture. So an example would be milk. Milk has lots of different substances in it. It has different types of proteins, it has different types of sugars, it has different types of fats, and it has water, and all of those together would be called a mixture. Mixtures can be separated by using what we call physical means, for example, boiling or freezing or melting, or filtering. Those are what are called physical methods, and we can use those to separate mixtures into substances. And then if the substances are made up of compounds, we can use chemical methods to turn those compounds into elements. Once we get to elements, we're kind of stuck. Okay? Now, there are 3 generally accepted states of matter that we discuss in chemistry. First one is called a solid. So figure 1.4 shows you molecular illustrations of solid on the left. In the middle we have liquids, and then on the right we have gases. Those flasks there are referred to as Erlenmeyer flasks, and we use those in chemistry. So the pictures here are showing you that for a solid, the atoms are really very orderly, right? If you look at them, they look like they're stacked up together, like someone put a lot of effort into stacking them. Solids often are highly ordered materials, meaning the atoms have regular patterns in terms of how they're arranged. The next material, liquids, are more disordered, right? There's more randomness in them. So they're trying to show you, for example, if you had water with a dye in it, it might look like that red substance in the middle. There's some movement that can take place, right? The molecules are able to move around each other, or the atoms are able to move around each other. So there's less order in liquids. Solids and liquids generally take up about the same amount of space. So if we have a certain mass, like, or we'll use weight. If I have a pound of a solid and then I convert that solid into a liquid by melting it, generally the liquid will have about the same amount of space. It takes up roughly the same amount of space. The third material, or the third state of matter, I should say, is called a gas. And so on the right side here, notice you really can't even see the material. When materials are converted into gases, often they become invisible. Not always, but often they do. And they're widely spaced and able to move around quite easily. In fact, they're bouncing around very much like if you were playing a game of pool or ping pong. Imagine you're playing table tennis and the ball is going back and forth. Gas molecules essentially do that. They bounce around very rapidly and they're very widely spaced. So solids and liquids, generally the spacing between the atoms is about the same, but in gases they're very widely spaced, so it occupies a much larger volume. So those are the three general states of matter. There's also a fourth called plasmas. So if you've ever seen a neon light, which is emitting light, right? The atoms in there are so hot that the electrons have been removed from the atoms, and so that would be a fourth state of matter, but that's not discussed here. Figure 1.5 shows you an example of all three states of matter for one material. And so the significance of water on our planet, it's, when astronomers are looking, or physicists are looking for the possibility of life on other planets, they look for water because water is believed to be a very important compound for life. Water is important, and so one of the things that water has the capacity to do is exist in all three states of matter, solid, liquid, and gas, in the same environment. So on the Earth, we have ice, right? And we have liquid water, the oceans and lakes and rivers. And we also have water vapor, which we call humidity. And all three can coexist in the same space. So this picture here is showing you that if you boil water with ice cubes on the top, all three of those states of matter can exist simultaneously. So let's talk a little bit more about elements and compounds. Figure 1.6 shows you in the first picture, the first diagram on the left, isolated atoms of an element. So notice all the little particles are orangish. They're all the same color. That's an element. So all the atoms are identical. So those could be helium atoms, or they could be neon atoms, or they could be sodium atoms. It looks like they're moving very rapidly, so they're probably gases. If you look at the next picture, B, what you'll see are examples of what are called molecules. There's more than one atom attached. So each of those have two atoms attached to each other, so those are molecules. But it's an element. So all of those atoms have the same color. Of course, we don't know what atoms they are, but they're all illustrated as being blue. That's an element. That substance there is elemental because they're all the same types of atoms. There's no yellow or red ones mixed in there together. If you move over to part C, in that diagram what you see is that we have molecules again. We have these clusters of atoms, but these are compounds, right? If you look at the center atom, which looks like it's sort of purple, it's surrounded by three green atoms. So one element, purple, second element, green. Those four atoms together make up a compound. So these molecules are examples of a specific compound. We don't know what it is. Could be ammonia or something like that. But those are compounds. And then on the right, in part D, you see that we now have a mixture. They put everything in there. So you've got the orangish element, you've got the blue elements, which are molecules, and then you've got the compound, which is the purple with the green. So all of those are in there. That's a mixture. And we could separate these into 3 different substances, 2 different types of molecules. One's a compound, the other one's an element, and then you also have the individual atoms, which are also an element. Okay. So read through here. When you get to figure 1.7, they're going to talk about different types of mixtures. There's generally considered 2 types of mixtures. One is called homogeneous, and the other one is called heterogeneous. And a homogeneous mixture is one in which all the substances that are mixed together, so we're talking about mixtures, it's the same all the way throughout. So for example, if you take some sugar and you dissolve it into water and stir it really well, the water at the top of the glass should have the same sweetness as the water at the bottom, and we would call that a homogeneous mixture. So sampling any part of the liquid will give you the same mixture. A heterogeneous mixture is the case where it's not the same all the way throughout. So in the picture here where they have these little iron filings mixed in with sand, the iron filings are clumps. And so if you take a little piece of that sand, a little portion of that sand with the iron in it, you might get more iron one time and less iron the other time. So that's what we would call a heterogeneous mixture, because it doesn't have the same composition all the way throughout. Okay. And then finally, in figure 1.8, there's a little flow chart shown here to give you a sort of overview of this classification of matter. So we're talking about matter. Everything that the universe is made out of can be made out of mixtures. And so the mixture, for example, a mixture could be sugar in water, and that would be a mixture because you have sugar and you have water. That would be a homogeneous mixture, most likely, if you've mixed it well. But imagine that you put a lot of sugar in, so much so that some of it falls down to the bottom, and no matter how much you stir, it doesn't dissolve. That would be a heterogeneous mixture because you've got that solid sugar down at the bottom. Now, we can use physical methods, boiling, freezing, filtering, to separate these mixtures into substances. And then we said there's 2 different types of substances. One are called compounds. So for example, sodium chloride has sodium and chlorine mixed together. That's a compound. And then we have elements. Pure sodium, that would be an element. Pure chlorine, that would be an element. And we can convert compounds into elements by using chemical methods. That would be called a chemical separation. So for example, if we use electrolysis, we use electricity, we can turn sodium chloride, which is a compound, it's a substance, but it's a compound, into the pure elements, sodium and chlorine. So again, no problems in this particular section, just a discussion here for your understanding. This will give you a little bit of background into materials and matter and how we classify them.